log in. If you don't, you can register. Once you log in, our control panel will give you courses, and under the courses we have csMOB listed, and we have our introduction week, week 1, that's HTML5, JavaScript, and Ajax, and then this week that we will see, we will start with Android. So going back to week 1, we saw some things with Ajax, and then we saw some things that YQL, Yahoo Query language, that we can go with the use of YQL, we can pull up data from sites like Google News or calendar or weather applications, and we can pull weather for certain places. So that's exactly what locale was. If you remember, if you just make a quick trip back, let's look at what locale does. Let's resize this thing so that it'll be nicely visible. So we have an input box and a submit button, and if you go and put in the zip code, I will put in 01970, which is a zip code for Salem, and we click on submit, it will pull up the news for Salem. But we mentioned that this program has a little bug, and the bug was the fact that if you want to now go and pull up the news for Boston, which is 02125, one of the zip codes in Boston, what we would expect is this area to be updated with the news that is consistent of the Boston news. But once we click on the submit button, what we get is another pile of news that's just stacked on the bottom of that previous news. And this will just keep going like this. If I just keep on submit button, it will kind of go and pile up one on top of another one. And this is not really effective way of achieving what we're trying to achieve here right now. So how could we solve this problem? There was another concept that we saw, Ajax, right? Last week we had an input box, and we went on to put in the stock symbol, which was good for Google. And once we click on the get quote, it gets the Google price and updates this region here, which shows us the Google stock price, and it doesn't refresh the page. It does that dynamically, pulls up the, it makes a server request, pulls up the news and updates that region. So what is today's, this week's project is to make use of these two files and fix the problem on locale, so that every time I enter a zip code here and hit the submit button, it updates only this region and shows me only the news that I'm interested in. So that's the project, and we have a little T-shirt that we made ACM. Those ones that are going to achieve the project, that are going to solve the problem of that project, is going to get this ACM T-shirt. So this will be given out next week. So guys, work on that project. It should not be that hard. So it should be pretty easy to solve. So if you guys have any questions, you can also contact me or contact us through, if you're an online audience, you can contact us through the contact button on the website. We have our emails and phone numbers listed on here. Or you can just find me at the department. So starting with this week. This is gonna be the first week that we're gonna, step into the world of Android. And with the starting with Android, we have to know there's some foundations that we have to lay. The foundational concepts that we have to know. So Android is a mobile application platform, and we've seen several of them under iOS. There's Windows 8 that's putting a lot of money into marketing these days. So there's various platforms, and we have seen advantages and disadvantages of all these platforms. Why develop a native application? Why develop a web application? So we're gonna concentrate on Android. And Android is an application that's developed on Java programming language. So when we say Java programming language, then the sensors in your brain should, pop up and think that, oh, if it's developed on Java programming language, there must be other programming languages that are available that this could be developed on, right? And yes, there are C programming language, there's C++, Python, there's so many programming languages out there these days. So then the question comes up, then why Java? You know, why Android picked Java? What is the advantages and disadvantages of this programming language? Why not pick C? So these are all valid questions to ask. And could it be the fact that, you know, guys who founded Android hated other programming languages and they liked Java? Yeah. But knowing the characteristics of Google employees, this is very unlikely. It probably offered some advantages and disadvantages. So it's good to look at those programming languages. And one of the core ideas about Java is that it's a programming language that is object-oriented, right? Object-oriented is a programming paradigm. And again, once I say the object-oriented programming paradigm, then sensors again should pop up in our brains saying that, oh, if there's an object-oriented programming paradigm, there must be other paradigms out there that we might or might not have heard of. So yeah, there are. There's structured programming paradigm, there's functional programming paradigm, there's object-oriented paradigm that we mentioned, there's imperative paradigm, and there's declarative paradigm. These are all the paradigms that are available. And structured paradigm is something, basically it's the structured programming language. So like if you have a programming language, inside we use a lot of statements that say go to this line, go to this line. And that paradigm, you know, these were very famous paradigms back in 60s, 70s, 80s. And they lead to, there's a term, I don't know if you guys heard, it's called the spaghetti code. And it's a very widely used term in the field of computer science if you actually go into the industry. And what is spaghetti code is, it's a code that's hard to follow, right? If we make a programming language that, you know, we go 3 lines and then we say go to line 128, and we go down to 128 and we follow, it says go back to line 10. So all these, you know, mix up our brain and kind of, they lead, if we don't know what we're doing, they might lead to serious bugs. And there are many other programming paradigms out there. They're functional, imperative, declarative. So what is object-oriented then? Java. Object-oriented programming paradigm. In here, as we know from the title, almost everything is an object. And what is object? Let's actually look at the, let me turn off the, okay. Let's actually look at what happens when we write a program. So when we write a program, we write a code that's called the class, the source code. Right? We write our source code, we place it on a file, and then we do something with this source code. And like I mentioned, there's a classical, you know, paradigm, that classical programming languages like C. There's many other C++. And these programming languages, we write a source code. So we have a source file, and this source file goes to compiler. Because what we write is not understandable by the machine. Machine only understands zeros and ones, as we know. So this source files go to compiler, and it turns into the thing that is called an object code. And as you know from your projects that you have done in your CS classes, that sometimes when we write programs, on top we include libraries, right? Include libraries that we can make use of already made functions to us. So there are other object codes that's available to us. I'm just going to write other object code. And these go to linker. And once they are linked, they turn into executable file. That we call our program. Now, this is the classical, classical way of what happens on the background. So we know that there are different operating systems available. There's Linux, there's Windows, there's Mac OS, So, and all these machines, they talk different zeros and ones. The zeros and ones that Mac understands is different than zeros and ones that Windows understand, and that's different than zeros and ones that Linux understand. So, so when compilers are made specifically for either Windows machines or Mac machines or Linux machines. So once we turn our code into executable file that can be run only one machine, like either on Windows or Mac or Linux. So Java said, I'm going to do things differently. Some guys at Java, they got together and they said that, this is not really a nice way of solving one problem. We want to write a program that can be run in all the machines. If we want our programs to be cross-platform. So what Java does is, we write a source code that we place on a source file. That goes to a compiler, and that turns into not an object code, but something that is called a class file. And there are other class files that are available, just like we saw. And these are numerical instructions for machine to follow, but not the computer itself. We're going to see later on what machine. These are numerical instructions for the machine to follow. These are sometimes also, this whole thing is called a bytecode. Sometimes this is also called the bytecode. This is not 0 and 1, but this is also not the language that humans understand. This is something intermediate language. There are some humans that understand this language who actually deal with all the core parts of Java, but we're not going to go into that part. So this is an intermediate language that's not really zeros and ones, but also not the language that humans understand, something in the middle. And these guys go into they link together and turn into a file that's called jar archive. Jar archive, well, actually JAR means jar archive, so I don't know why they call it jar archive, because it kind of sounds like Java archive. But this is what it's called, jar archive. And now this file, which is again some intermediate language, goes to virtual machine that's called JVM, Java Virtual Machine. Java Virtual Machine is installed on our computers, and they know how to talk to Windows. They also know how to talk to Mac, and they also know how to talk to Linux. So we don't have to deal with the lower parts, what this Java machine does. We only write a code that Java machine understands, and the rest is up to Java machine that can interpret that language. And JVM gives us the result, our program that says hello world. So this is the way that Java does things. And we say Java is an object-oriented language. So what is object-oriented paradigm? What is different than classical languages? So it's very important to understand object-oriented language, because in Android, we make full use of it. So let me clear up the board here. So we said we had different programming paradigms. We had functional programming paradigm, structural programming paradigm, declarative, imperative. So all these paradigms were widely used back in 70s and 80s, but they were kind of limited. They limited us in terms of the scale of the project. They didn't let us go and write into very big projects. And what do we mean by big project? There's a project that can be written by one guy, one programmer, but there's also a project that can be written by 20 other developers. And I guess that's obviously is going to be a bigger project, but how do you write a program with 20 other developers and make them all talk to one another and bring it all together, interface that with one another, and as a result bring out a good big project? So Java kind of offers a good solution. Not Java, object-oriented paradigm kind of offers a good solution to solve all these problems. And we make use of a concept that is called inheritance. And in Java, we have things that are called interfaces. We basically put skeleton files and we distribute it in between our developers that they all have to inherit that interface and write their whatever part they're working on. So that way our written pieces can talk to one another precisely. So how do we understand all these things that is called inheritance and objects? What is object? What is class? It's a very confusing thing, and a lot of developers confuse what is class and what is object. They sometimes call it they're the same, sometimes call it they're different. So it's very important, I guess, to understand those. So let's, in concept, write a program that's going to involve humans. So we'll make a little trip back to our high school years in terms of the biology, because this hierarchy includes biology. So we have human, right? And we know that humans are primates. Yeah, not have to go a little down here. So we have humans, and we know that all the humans are primates. And we know that all the primates are mammals. And all the mammals are animals. So this is a kind of hierarchical chart that goes up to this way. I believe this is a really, really good way of explaining object-oriented program, and I actually borrowed this from a professor that teaches CS106A. It's a class at Stanford University, Mehran Sahami. This is really perfect way of understanding object-oriented program and the concept of inheritance. So we have humans. All the humans are primates, and all the primates are mammals. Therefore, all the humans are mammals. And we know that all the mammals are animals. Therefore, all the humans are animals, primates are animals, mammals are animals. So if we have a human, and all these parts have their own behaviors. So if we have a human, we know that humans have to carry the behaviors of primates, mammals, and animals. So let's put down some behaviors. We know that animals digest food. And their embryos pass through cholesterol strait, whatever that means. Embryos pass through cholesterol state. I don't even know how to spell cholesterol, but so these are the behaviors that belong to animals. Now we have some mammals, and we know that mammals are warm-blooded. So they are warm-blooded, and they have mammary glands, right? And that's why they have the name of mammal. They have mammary glands. And primates here, they have 5 fingers, and they have opposable thumbs. And then we are down to humans who have, I guess, highly developed brains. Well, I actually won't put highly here because sometimes that might not be the case. I'll just put brains. So let's say we want to construct a human. Do we want to start from animal and develop all the way down every single time we need a human? Or, and let's say we're making a human, but there's no one person that's human, right? There's one person, it's an example of human, there's another person, an example of human, and all the people out there, they're samples of humans. So every time we create a human, usually it's a person that has a name, it has a last name, it has some family history, so that would be an instance of human. So if we create, let's say, me, so we have Bala, we have Bala. Bala is an instance of human. Now, Bala here is an object. Human here is a class. So it's important to understand here that Bala cares all the behaviors of human, primate, mammals, and animal. But we don't have to, every time we need to create a human, we don't have to create all these things. We can inherit all of them by saying that create Bala, new Bala, that extends human. Just with saying that, we create an object that inherits all the properties of its hierarchical chart. So we create another object, let's say John. John is another object, and it's also an instance of human. Now John and Bala, they have all the properties of this above chart, but they can have separate properties by themselves. Bala can have a last name which is Sultan of John, can have a last name which is John's. So we can also take the properties that inherited from this hierarchical chart and customize them based on these objects. So we say John is an object, Bala is an object, human is a class. These objects are inheriting. Then is human a class or object? Human is a class for these guys here, but human is also object which inherits properties from primates. Human is an object for this class. And is there another class? We can say monkeys. Monkeys are also primates. They're not humans, but they're primates. So these guys are objects for this class. So that's the hierarchy that we have to follow in order to understand the object-oriented paradigm. So by saying that, we will step into Java and look at some sample codes. Alright, so if we click on slide 1, slide 1 is an actually downloadable file, so it will download it. So if you open this is actually a presentation from my senior project, which is, let me actually do this. So I actually didn't delete this part because I found this very useful in terms of mobile applications. This is just some statistics from eMarketer that was estimating the users. And in 2012, they said that users of the smartphones in US is going to reach the value of 115 million. So our users are growing, and they expected that by 2016 it was going to reach to 200 million. So we kind of have a feeling that computers are kind of fading away, and all the users are going into mobile devices. So I guess that's a really good way of defining the importance of mobile applications, and the fact that if you want to make an application and you're targeting users, it's better to make a mobile version of it. So we went over and just showed the structure of how how we write a source file and it's turned into an executable file. And we gave an example that Java, Android is developed on Java, but how does Android actually goes to a form of executable file? It's almost same as Java, but a little different. So we saw that we write a Java code. We write a source code that's Java, and that code goes through some compiler. And they're both using Java-C compilers, and it's being compiled from Java code to a class file, which is an intermediate language. All right, so we're coming same until this point. We write Java code on both of them, we compile that down to class file,